Welcome back to AP Statistics with Mr. Walton. Today we're going to talk about our chi-square goodness of fit test, which is under our inference for categorical variables. Where our chi-squared procedures, remember chi-squared is the same thing as that squiggly x to the second power. Goodness of fit can be abbreviated as GOF, G-O-F. Our test statistic, we need to keep track of, our test statistic is the summation of O minus E quantity squared over E. We're going to think of our degrees of freedom as k minus 1, where k is the number of categories, or k is the number of cells in our one-way table. O is our observed counts, and E is our expected counts. Please remember, all calculations are to be done using our count data. Do not use proportions. Our underlying question, we want to keep this in mind, is which one of these pieces of O minus E squared over E values contributes most to a significant finding, because then that helps us narrow down our next question for research. For our hypotheses, the proportions are the same. List our proportions equal to those numbers for all proportions, and H sub A, at least one or two proportions differ from the hypothesized proportions, or the ones that are advertised, or the ones that are given. We want to keep that in mind. What are the properties of our density curve? Total area is 1. Other than df equal to 1, it is skewed to the right. Looks like this, approaches the x-axis asymptotically. As we move on, we need to keep that skewed to the right always, always, always. And it does become more symmetrical, but it still remains skewed to the right. Think right. Yes. First quadrant. Yes, that's what we're talking about. Inference toolbox. Here we go. Number 1. What am I going to do if I'm looking for thinking about solving, completing a free response question? I want to think about number 1, define my parameter, write my hypotheses. I want to think about my conditions. I want to have my randomness, my independence, and that all of my expected counts are greater than or equal to 5. And that's what allows us to proceed with our goodness of fit test. If you want to think about IR, independence, randomness, expected counts, you can be mad, but you can answer your conditions or list your assumptions. Next up, for calculations, what do we need to make sure we have? Okay, we're going to make sure that we have our test statistic, our degrees of freedom. We're going to make sure we have a picture. We're going to make sure we have a probability statement. We're going to actually calculate the p-value. Okay, a little asterisk next to our beautiful, lovely test statistic means we definitely need to make sure we have our observed and expected counts listed somewhere so that we can show where we're garnering or gathering the information to calculate our test statistic. And lastly, money statement. Money, money, money. Interpret in context. What are we doing? All right, that's our brief overview. Now, let's look at a problem. What we want to know is, are the birthdays of world-class soccer players evenly distributed across the 4 quarters of the year? And secondly, what conclusions can be drawn from this study? So, let's look. First thing, let's set up our expected counts. These are the observed. So let's set up expected. All right. So based on this, they should be equal. In this, I have an n equal to 528, so I would expect them to be equally divided, so I would expect 132 for each. There we go. Now that I have that set up, what are my hypotheses? And then my alternative is at least two proportions differ. All right. Next up, conditions. We're thinking ire. So we've got we're going to consider the inclusion in the World Cup of players to be random, as not all world-class players are able to play in the World Cup, depending on whether their country is included or not. For independence, it is reasonable to assume there are more than 5,280 pro soccer players Therefore, this sample of players should be independent. And E, so we might be saying, since all expected counts we will continue and calculate a chi-square goodness of fit test. So, my test statistic is the summation of okay, we're looking at this, and when I calculate for my p-value, I got and then money statement. So I'm rejecting H sub O because P is lower than alpha. Okay, so the evidence suggests, and this is our conclusion, that birth months by quarter for world-class players of soccer are not evenly distributed. All right, so there's chi-square goodness of fit. Hopefully this will help you better understand the concepts for the chi-square goodness of fit test.